Alright, so here is our Math 1 Term 1 project. I'm going to kind of go over a few things, maybe talk about some kind of examples, hopefully just so if you're stuck or struggling, this will help you kind of figure out what it is I'm expecting you to do. Okay, so we're trying to kind of talk about algorithms. They're all over the place in life. We use them a ton in math. Basically a step-by-step way to do something. Okay, and I'm trying to connect this idea of a path in driving with evaluating and solving equations. So here's kind of what you're supposed to do. You need to print out a map and plot a course from a starting point to a destination. Okay, and let's not make it too simple. Okay, we want it to be fairly complex. On your paper, I kind of gave you my example. Okay, but let's take a look a little bit more at this. Okay, so the first step is just picking one. So I'm going to go from Tooele to Dow James. Okay, so I'm driving in my vehicle and I pull out here onto Vine Street, turn right, then I go up, I guess north on 200 West, and I'm going to go here on Griffith Street because I'm just going to pretend like I stopped here and had somebody to pick up or drop off. So I turn left on Griffith Street, follow that, which then turns to Landmark, so I turn right onto Landmark, then I turn left onto 400, and then over here's the parking lot, and I arrive. Okay, so here is my path. Okay, so step-by-step directions, what am I saying? Well, I want to say something like I leave the parking lot by turning right onto Vine Street. Okay. Then I travel till I get to 200 North, so then I turn left. And we don't need to put distances. You can if you really want to, but we don't need to. Turn left on 200 West. Okay. Driving north. Alright. So that's taken me right there, and then I'm on that path, right? Then once I get to Griffith Street, I turn left onto Griffith Street. I'm not going to write out Griffith. Okay, and then I drive, and I would say, keep turning, going east, or going west, I meant. Okay, then right at Landmark Drive. I know you can't really, I'm writing really crappy, but you're listening, so that should be enough. Okay. Might want to mark kind of what's happening. So I turned right. Then when I get to 400, I turn left on 400 North. Then turn right into parking lot at Dow James. Okay? So there's my path, right? That's how I traveled. Okay? That's the first step. So that was part 1. Okay? I also did part 2, right? Write a step-by-step version of this path. Okay? And yours, not the maps programs. Okay? We're doing it on our own. Okay? So you do need to be drawing this on a map, and that can be electronically drawn or by hand. Okay, then we're going to return back and do a step-by-step version of the return path. So, now if I'm going backwards, I would turn right onto 400 North, going east from the parking lot, right? Then turn left onto Landmark Drive, okay? Which then I turn another left onto Griffith Street. Then I turn right onto 200 North. Then when I get to Vine Street, we turn right onto Vine. And I can write going south, going east, going west on all these. Then, turn left into THS parking lot. Okay, so we do the return back and do the step-by-step. Okay, so those are the first three things we're going to do. Then on 4, we're going to create an equation or inequality, could be either one, with at least one variable. You could do more if you wanted. And again, we want it to be more complex, not just x equals 5, something simple like that. Okay. Again, I've kind of tried to do some examples, and we have these examples in our notes that we took on one of those days. So, I'm not giving you any extra hints here by doing that. But I create that equation. Okay. So my equation I created, we're just going to use that one. Okay. Which, there's my equation. Negative 86 equals negative 2 times 6x minus 5. Okay, it's not super complex, but it's a pretty good one. Okay, so what I need to do is find what the variable is equal to and evaluate for that number. Again, writing down the steps of what I do. Okay, so I'm not going to rewrite that because I kind of did it here. So I found out that, and I went and solved it first, honestly, to figure out what that was. But I took my equation, kind of dropped what it was equal to, and said I knew that x was going to be 8. So I go 6 times, I plug 8 in there, and I evaluate. So I'm using order of operations. So first I substituted. Then I multiplied 6 times, I don't know why I put a 9 there, that should have been an 8. Okay. So, typo there. Fix that on your own paper. That gave me 48. Then we subtracted 5, which gave me 43. Then I times by negative 2, got negative 86. Okay? So, that's writing down the steps and finding the number and evaluating. Okay? Then I'm going to work backwards because I know it's equal to negative 86, and I'm going to solve it. Okay? So, I solved by dividing by negative 2, and I wrote down what I did. Then added 5 to both sides. Then I divided by 6 and got 8 equals x. Okay. Then I also had to write down the justification. So I put same thing, and I added a few justifications, and then wrote down all those properties of equality we talked about. Okay. So I need all of that stuff together on pages. They can all be handwritten, it can be typed, it can be done electronically. Okay, so kind of like looking at number 8. I don't want these on poster boards, please, nothing poster board style. So either electronically, that could be a Word document the things are put on, that could be a presentation as long as I can access it, or portfolio style, aka a bunch of pages stapled or put in a nice little folder. Okay, something like that. That's how I want these turned in. Okay, so this could be its own page, or these each pages separately. This their own page, or together. Okay, so all of that. Okay, now the part that I'm not going to help you a whole lot on is number 7, because now what you have to do is you have to kind of figure out, compare and contrast how going this direction and what we're doing, and then going back, how those relate, okay, and then kind of comparing those as well, okay. You should notice some patterns, and thinking about those notes we took when we talked about how we solve with equivalent equations and doing inverse operations in reverse order, things like that, should be what you're looking at, and you should notice a pattern, and you can kind of think of the evaluating is like one path, the solving is like the other path. That's kind of, I guess, the hint that I'll give you. But it should be 3 to 4 paragraphs. Okay, they don't have to be massive paragraphs, but you do need to clearly state what you're trying to tell me about. Okay, so that's kind of the main gist of it. So again, it can be electronic or just on pages, so you'd have, a separate page with all of that as well. Okay, now the way I'm going to point, I guess grade it, not point it, is looking at, here's how many points are possible with each part. okay, out of 100 points. So the more complex the path and the equation, the easier it's going to be to get the full points. If it's super simple, you're going to be docked some points because I do want you to try a little bit more on this. Okay, making sure that you're doing good quality and showing things. Again, I guess complexity of directions and equations, I made it its own category, so I'll judge that separately. I guess I was kind of lenient on that. So anyway, in that rubric you'll need to have with it so that I can mark down when you turn it in. Okay, so due date, October 22nd, that is right before the end of the term. That should be plenty of time for you to get it done. You've got this video that should hopefully give you some clarification. If you have specific questions, you definitely need to come in and talk to me. And basically, there we go, guys. So get it done, hand it in, and good luck. It is worth quite a bit, so you definitely want to get it done.